Hello everyone, I am Dr. P. Magesh Kumar from the Department of Civil Engineering, K.S.Rangasamy College of Technology. Welcome to this lecture on wastewater treatment. In this session, we will understand why wastewater treatment is essential, the types and characteristics of wastewater, different stages of treatment, modern treatment technologies, reuse possibilities, and the challenges involved. The topic is very important from the perspective of public health, environmental protection, and sustainable development. Water is a vital and irreplaceable natural resource. It is essential for human life, public health, agriculture, industry, and maintaining ecological balance. However, due to rapid population growth, urbanization, and industrialization, the demand for fresh water has increased tremendously. At the same time, the quantity of wastewater generated has also increased. Untreated wastewater contains organic pollutants, nutrients, pathogens, and toxic substances. If discharged directly into rivers, lakes, or soil, it leads to water pollution, spread of diseases, and environmental degradation. Therefore, the wastewater treatment becomes essential to protect surface and groundwater resources. Properly treated wastewater can be safely discharged or reused for irrigation, industrial purpose, and groundwater recharge, thereby promoting sustainable water management. Next, the objectives of wastewater treatment. The main objectives of wastewater treatment are clearly defined. First, to remove physical, chemical, and biological contaminants, including suspended solids, organic matter, nutrients, pathogens, and toxic substances. Secondly, to protect public health by preventing the spread of waterborne diseases such as cholera, typhoid, and dysentery. Third, to protect the environment by minimizing pollution of rivers, lakes, and groundwater bodies. Another important objective is to enable safe reuse of treated wastewater for agriculture, industry, and construction activities as well. Overall, wastewater treatment supports sustainable water management and conservation of freshwater resources. Next, the types of wastewater. The wastewater can be broadly classified into three types. The first is domestic wastewater, also called municipal sewage. It is generated from households, institutions, and commercial buildings. It mainly contains organic matter, nutrients, detergents, suspended solids, and pathogenic microorganisms. The second type is industrial wastewater. It originates from industrial process and may contain toxic chemicals, heavy metals, oils, acids, alkalis, and high organic loads. This type of wastewater often requires specialized treatment before discharge. The third type is stormwater or rainfall runoff, which results from rainfall flowing over roofs, roads, and open areas. It carries sediments, oils, debris, nutrients, and pollutants into drains and nearby water bodies. The characteristics. To design a treatment system, it is important to understand the wastewater characteristics. Physical characteristics include color, odor, turbidity, and temperature. These indicate the presence of suspended solids and the general condition of wastewater. Chemical characteristics include parameters such as pH, BOD, COD, nutrients like nitrogen, phosphorus, and heavy metals. These indicate the pollution strength of wastewater. Then biological characteristics refer to the presence of pathogenic organisms and microorganisms such as bacteria, virus, protozoa, and helminthes, which pose serious health risk. Wastewater treatment carried out in several stages. It starts with preliminary treatment, which removes larger solids and grit. This is followed by primary treatment, where suspended solids are removed by sedimentation. Next is secondary or biological treatment, where microorganisms degrade organic matter. Then comes tertiary or advanced treatment, which removes nutrients, pathogens, and residual pollutants to improve effluent quality. Finally, sludge treatment is carried out to stabilize and safely dispose or reuse the sludge generated during treatment. In preliminary treatment, the focus is on protecting downstream units. Screening removes large floating and suspended materials such as rags, plastics, papers, and sticks using coarse and fine screens. Grit removal separates heavy inorganic particles like sand, gravel, and silt in grit chambers. The main purpose of preliminary treatment is to remove debris, protect pumps and pipes, and improve the efficiency of subsequent treatment units. In primary treatment, wastewater flows slowly through sedimentation tanks. However, heavier settleable solids sinks to the bottom forming sludge, while floating materials like oil and grease are skimmed off the surface. This process removes a significant portion of suspended solids and part of organic load. Typically, primary treatment achieves about 50 to 60% removal of suspended solids and around 30% reduction in BOD. This reduces the load on secondary treatment units and improves overall system performance. Secondary treatment is the most important stage for organic matter removal. It uses biological process such as the activated sludge process, trickling filter, oxidation ponds, and moving bed biofilm reactors. In these systems, microorganisms consume and decompose organic matter, converting it into carbon dioxide, water, and new biomass. Secondary treatment typically achieves 85 to 95% removal of BOD and COD, producing clarified effluent suitable for discharge or further treatment. Tertiary treatment is also known as advanced treatment. It includes advanced filtration methods such as sand filtration, membrane filtration, like microfiltration, ultrafiltration, nanofiltration, and finally reverse osmosis. And disinfection using chlorine, ultraviolet radiation, and ozonation is carried out to destroy pathogenic microorganisms. Advanced process also remove nutrients such as nitrogen and phosphorus, preventing eutrophication. This stage ensures that treated water meets reuse or discharge standards. Sludge generated during treatment must be properly managed. Thickening reduces sludge volume by removing excess water. Digestion can be aerobic or anaerobic. Aerobic digestion produces biogas which can be used as an energy source. Dewatering further reduces moisture using centrifuges, filter press, or drying beds. Finally, treated sludge can be disposed safely or reused as compost, soil conditioner, or for biogas generation. The wastewater treatment technologies can be classified as conventional and modern. Conventional system like ASP, oxidation process, oxidation ponds are reliable but require large land area and continuous monitoring. Modern technologies such as MBBR, SBR, and MBR offer compact design, high efficiency, and better effluent quality. With the integration of automation, sensors, artificial intelligence, and IoT, treatment plants are becoming smarter, enabling real time monitoring, predictive maintenance, and optimized performance. Today, wastewater treatment plants are becoming resource recovery facilities. Treated water can be reused for irrigation, industrial cooling, construction, and landscaping. Biogas generated during the sludge digestion can be used for electricity or heat generation. Nutrients like nitrogen and phosphorus can be recovered and reused as fertilizers. This approach supports the circular economy and sustainability goals. Despite technological advancements, several challenges exist. High treatment costs and energy requirements limit implementation of advanced systems. Lack of public awareness and improper waste disposal behavior affects system efficiency. Many rural and rapidly urbanizing areas lack adequate sewer networks and treatment facilities. Additionally, climate change impacts such as flood and droughts affect collection system and treatment efficiency. To conclude, wastewater treatment is essential for public health, environmental protection, and sustainable development. Efficient treatment, reuse, and resource recovery can significantly reduce freshwater stress and pollution. With the adoption of modern technologies and smart systems, wastewater management can move towards a sustainable and resilient future. Thank you for watching this lecture.